Hello everyone. So today we are going to discuss one of the important topic from current affairs that is nowadays very much approaching. And if we talk about the exams that are there in nearby times, that is your Civil Services 2023, EPFO notification has also been released. CDS exam is there, CAPF exam is there, UPPCS 2023 is approaching. So it becomes very important for your exam perspective, because if we talk about world geography, specifically about world geography, like whatever the places that are there in news, it becomes anyways important. So today we will be discussing about the earthquake, like it's a static portion, as well as about the earthquake that has hit the region of Turkey and the nearby places. So we'll look into it, we'll try to figure out like why this is happening, why the earthquake was so devastating, and what is the idea behind that. So let's discuss. So first of all, we need to discuss like why Turkey, okay, why this area only and why not the other places. Like if there is some geographical constraint, so yeah, there is something, because 7.8 magnitude had struck. And not only this, if we talk about last 10 years, thousands of earthquakes have struck in this region. Not only this, like in 2020 itself, approx 3,000 earthquake hit this region. But yeah, the earthquake was very small and it was not that sensitive. That's why it was not very much into news. So we have to understand like why this is happening and why it's 7.8. So first of all, this is happening near a fault line, that is the Anatolia tectonic block. Now it emerged from a shallow depth, and this were a strike slip quake. Now what is strike slip quake? We need to understand that as well. It is being described as the strongest earthquake that Turkey has experienced in over a century, and one of the worst disaster after 1939. So yeah, let's come to the point like why this is the extreme devastating one. So what makes Turkey prone to earthquake? First of all, we need to understand like the geography behind that. So first of all, in the eastern Mediterranean region, which comprises of your Turkey, Syria and the Jordan, these tectonics are dominated by complex interaction between the African plate, the Arabian plate and the Eurasian tectonic plates, and specifically the Anatolian tectonic block. Okay, and you know what, 95% of earthquakes in the world are caused mainly due to the tectonic plates. Rest 5% can be, from various factors like human activities and other factors can be considered over here. But 95% is mainly done from the tectonic plates. So what are these tectonic plates? Like if we need to understand about the tectonic plates, see there are three types of tectonic plates. Like number one is the convergent plate tectonics, which is like there are two plates that are coming towards each other, and this is actually a destructive one. Secondly, that is your divergent plate tectonics. That is actually divergent. Okay, this is moving apart. So this is actually a constructive one. Why this is a constructive one? Because if we see the example of rift valleys, so rift valleys are actually majorly these are made by this divergent plate tectonics. For example, the Red Sea Rift Valley, that is made by this divergent one. And the third one, okay, the third and the very important one, which is actually responsible for the Turkey earthquake, that is your transform. So what happens, like the plates are actually rubbing, okay, they are rubbing towards each other. That's why it is one of the destructive one, and a friction is happening. Okay, a lot of friction is happening here between the rocks. That's why the earthquake is very devastating, and this is what that has happened over here. So Turkey sits on the Anatolian tectonic plate, which actually borders two major faults, that is your North Anatolian fault, that is NAF, that curves across the country from west to east, and the East Anatolian fault. Now this is the meeting point where the Eurasian and the Anatolian tectonic plates are moving, okay, and they are meeting and rubbing towards each other, and this is considered as the most devastating. Now let's see the diagram so that you can understand it in a better way. So yeah, here you can see this is the African plate, this is Syria, this is your East Anatolian fault, this is your like North Anatolian fault, this is your Anatolian plate, this is the Gaziantep, okay, this is the epicenter, okay, like epicenter is just above the focus, okay, we'll look into that, okay. So this is your Arabian plate and here you can say the Eurasian plate. So you know what is happening, like this is going here, this is approaching towards each, like this parallel plate, and here this Eurasian plate is static one. So they are rubbing towards each other, and this is the meeting point of the Eurasian Anatolian, and that is particularly very devastating. And you know, this is the region where, you know, there's a hugely populated area, okay. That's why, you know, if we talk about according to data only, like more than 4500 people have been killed, and there's so many people they are missing. But yeah, that is the main reason why this area is very devastating, because of the transform plate tectonic boundaries and the way they are rubbing towards each other. Now there are three types of faults, like you must have you know, listened in news that this is strike slip, okay, this is a strike slip quake. Now what is a strike slip? Strike slip is basically when the two plates are striking towards each other. Now second kind of slip, or you can say second kind of fault, is your dip slip, okay, like whenever there is a vertical slip in the plates, now that is a dip slip. And the third one is oblique slip. Now oblique slip, there is a, you know, vertical dip, there is a lateral dip. So yeah, there are three kinds of faults that actually happens during an earthquake, and this one was a strike slip earthquake. So this can be a potential you know, question for your exam, like what kind of earthquake was this. So yeah, in addition to this, like why Turkey is majorly prone to earthquake, we have the Aegean Sea plate, which is located in the East Mediterranean Sea under the southern Greece and western Turkey. That is also a source of seismic activity in the region. And one estimate says that almost 95% of Turkey landmass is prone to earthquake. So here you can see, like this is your East Anatolian fault, this is your Dead Sea, this is the North Anatolian fault, and this is your Anatolian plate, and this is actually the reason where the earthquakes are happening. So I hope a little bit of concept is clear, like why this is happening in this region. Now we need to understand about earthquake. So what is earthquake? A sudden shaking in the earth's surface, right? That is earthquake. So in simple terms, it is the shaking of the earth. It is a natural event, like क्या बोल सकते हैं, like is there any way so that we can figure out like why this earthquake is happening or when this earthquake is happening? See, as of now we don't have such kind of technology, like we get to know about the earthquakes maybe you know, few minutes, in very few minutes, and if it's a highly densely populated area, then that area cannot be evacuated. So you know, a lot of times these things were happening in Turkey area, and there's so many factors responsible for that. Not only these factors like the geographical factors, apart from that there are little bit more factors. So we can just pray to God that the people gets evacuated, and there can be a kind of peace in that region. So yeah, now we talk about this earthquake. So the vibration called seismic waves are generated from earthquake that travels through the earth and are recorded in an instrument which is called seismograph. Okay. Now the location which is below, or you can say the earth surface, is called hypocenter, or you can say focus. And exactly above the hypocenter is your epicenter, like the location where the earthquake was recorded first. So yeah, this is the picture you can see. Now this is the fault, okay, this is the focus, like this is the fault, like three kinds of fault can happen over here. Then we have the focus, and exactly above the focus, like this is the point, is your epicenter where the earthquake is recorded first. Now these are the wave fronts. If we talk about the wave fronts, like the types of waves that can be experienced in an earthquake, so mainly we have two waves. Like number one is your body wave. Now this body wave can be of two types. Number one is P wave, or you can say primary wave. So primary wave is, this actually travels through the solid, liquid and gas. And secondly, we have the secondary wave. Okay, so secondary wave, this travels only through the solid. Okay, so we had an experiment, and as you know, like we have, this is your core, this is your mantle, and this is your crust. So what happened when waves were propagated? It slightly deviated from this place. Why? Because this was liquid and this core is purely solid in nature. So this was considered as shadow zone. So yeah, that's why we say that, you know, secondary wave travels only through the solid. Okay. And the third kind of, the second category is your surface wave. Okay, so surface waves are only experienced on the surface of the earth, and yeah, it can also travel through the solid, liquid and the gas, the three mediums. So yeah, that's about the waves. Now we talk about like the earthquake based on the depth of the focus. Now this can be a potential question, like what, how can we measure the depth of the earthquake, and what are the three types? So number one, we have the shallow earthquake, which is having a focus of 0 to 70 kilometer deep. Secondly, we have the intermediate one, which is having a focus of 70 to 300 kilometer. And the third one is deep earthquake, which have a focus of 300 to 700 kilometer. So you just have to, you know, understand, you just have to look into these points, because this can be asked in your exam. Okay, like this is a static portion one. Now, uh, so where the earthquake is happening the most. So if we talk about, like, I believe you all have heard about this Pacific Ring of Fire. So yeah, the world's greatest earthquake belt, which is the Circum-Pacific seismic belt, is found along the rim of the Pacific Ocean, where about 81% of our planet's largest earthquake occurs, and that's why it is named as Ring of Fire. So yeah, this is Ring of Fire. This is Hawaiian hotspot. This is, you know, the Aleutian Trench. This is your ring. This is the Indo-Australian plate. This is Eurasian. This is North American. Yeah, so this is the area where most of the earthquake, like Earth's 81% earthquakes are happening. Now, we talk about little bit from Indian context. So this is actually given like earthquakes zones. Like India was divided into different zones in accordance to their severity and how we can work accordingly, right? So we have these four zones. So zone 2 is actually very low risk zone. Then we have zone 2, which is moderate one, zone 4, which is high risk, and zone 5. So here you can see like this one, or maybe this or this northeastern zone. This is a very high risk zone area. So yeah, that's all about earthquake, and you need to just focus on the facts. You need to focus on the area where it is happening. From geography context, you can just check out the area near the Red Sea, Black Sea, okay, the bordering states, the states which are near, you know, this Turkey area. What are the countries that are bordering Turkey? So yeah, this way you can prepare your earthquake reason, and this can be a potential question. So yeah, we'll be discussing more and more in the coming lectures, whether it's from the perspective of current affairs or maybe some static portions as well. So thank you so much for having your time over here, and I wish you all the best for the coming exams. Thank you.